So, you've probably heard of parallel universes before, those mind-bending ideas where every decision you make splits the universe into a new version of itself. Sounds like something out of a sci-fi novel, but guess what? Scientists are actually getting serious about this idea, and it's not just about fictional characters running around in spaceships anymore. Think of it as the universe's way of saying, hey, there's more to life than what we can see. And if you're wondering how that even makes sense, let me break it down for you like I'm explaining it to my younger sibling who's trying to wrap their head around quantum physics. The concept of parallel universes has been around for a long time, way before the internet and social media made everyone a conspiracy theorist. Back in the early 20th century, physicists were already debating whether our universe could be just one of many. It wasn't until the 1950s that Hugh Everett came up with the many worlds interpretation of quantum mechanics, which suggested that every possible outcome of a quantum event actually occurs in its own separate universe. That's like saying if you flip a coin and it lands on heads, there's also a universe where it landed on tails, without even needing to look at it. But hold your horses. This isn't just some wild theory that scientists came up with during a late-night brainstorming session over coffee and pizza. In recent years, breakthroughs in theoretical physics have given this idea more credibility than ever before. Researchers are now using advanced mathematics and high-energy particle experiments to explore the possibility that our universe might be part of a vast multiverse. Imagine if every single choice you've made since birth has created an infinite number of alternate realities. Some where you chose chocolate over vanilla, others where you never even got out of bed on your birthday. So, how exactly do scientists study these parallel universes? Well, they're looking for subtle clues in the way particles behave and how energy is distributed throughout the cosmos. One idea is that if there are other universes, they might be influencing our own through something called cosmic strings or by leaving behind traces of dark matter and energy. It's like trying to find a ghost by looking at its fingerprints, except these fingerprints are made of things we can't see with the naked eye but can detect using super powerful telescopes and particle accelerators. And here's where it gets even more mind-blowing. Some theories suggest that if we could somehow communicate or travel between these universes, we might be able to explore alternate versions of ourselves. Picture this, there's a version of you who won the lottery, another who became a famous musician, and one who never even learned to ride a bike. It's like having an entire universe-sized resume of your life, and now scientists are trying to figure out if that resume actually exists. Imagine if every single decision you ever made created a new universe, each one branching off like the choices in a video game. That's basically what the many worlds interpretation of quantum mechanics suggests. In this theory, whenever something happens with more than one possible outcome, like whether your coffee is hot or cold, each outcome actually creates its own separate universe. So, if you decide to take the left turn instead of the right, there's a parallel version of you in another universe who took the right turn. It's like having an infinite number of alternate versions of yourself living out every possible life path. But wait, that's just one flavor of the multiverse. There's also cosmic inflation, which is more about how our own universe might be just one part of a much larger structure. Cosmic inflation suggests that in the early moments after the Big Bang, the universe expanded at an unimaginable speed, so fast that it created regions where space-time stretched out into separate bubbles, each with its own set of physical laws and constants. These bubbles are like distant islands floating in an ocean of nothingness, and some scientists believe our universe is just one of those bubbles. Now, here's where things get even weirder. Some models of the multiverse suggest that there could be universes where gravity doesn't exist, or where time flows backward. In one particularly wild theory called the eternal inflation model, new universes are constantly being born from the same inflating space we're in now. It's as if our universe is just a tiny bubble in an ever-expanding foam of realities, each one with its own unique set of rules for how things work. But don't worry, this doesn't mean you'll suddenly find yourself in a universe where gravity is reversed, or where your coffee can be both hot and cold at the same time. These theories are still very much in the realm of speculation. Scientists use mathematical models and observations from experiments like the Planck satellite to try and understand whether these ideas have any basis in reality. So far, there's no direct evidence for parallel universes, but the lack of proof doesn't mean they're not real. It just means we haven't found the right way to look yet. What makes this theory so fascinating is that it challenges our understanding of what's possible. If multiple universes do exist, then everything we know about physics and even ourselves might be just one version of a much bigger story. And who knows? Maybe one day we'll have the technology to explore these other realities, like scientists finally figuring out how to teleport across galaxies or red mines. Until then, we can keep imagining all the strange and wonderful things that might be happening in the multiverse. Quantum mechanics has always been a bit like a mystery novel, full of strange characters, unexpected twists, and a plot that defies common sense. At its core, it describes the behavior of particles at the smallest scales, where things don't act like the objects we see in everyday life. Instead of moving predictably, these tiny bits of matter seem to exist in multiple states at once, only settling into one when observed. This strange property, called superposition, has long hinted that our universe might be more interconnected than it appears, and now scientists are using this weirdness as a tool to explore the possibility of parallel worlds. One of the most fascinating breakthroughs in quantum mechanics is the development of quantum computing. Unlike classical computers, which use bits that are either 0 or 1, quantum computers use qubits, which can be both 0 and 1 at the same time. This allows them to process vast amounts of information simultaneously, making them incredibly powerful for solving complex problems. But there's more than just speed here. Quantum computing has opened up new avenues for exploring the fabric of reality itself. By simulating quantum systems with unprecedented accuracy, researchers are beginning to test theories that suggest our universe might be just one of many, each existing in its own unique state. Another mind-bending concept from quantum mechanics is entanglement, when two particles become linked in such a way that the state of one instantly influences the other, no matter how far apart they are. This phenomenon has been described as spooky action at a distance by Einstein himself, who found it so strange he doubted its validity. Yet, experiments have confirmed that entanglement is real and can be used to create secure communication channels and even teleport quantum information across vast distances. What's more intriguing is that these connections might not just exist within our universe, but could also span multiple realities, offering a potential bridge between parallel worlds. Recent advancements in quantum technology have allowed scientists to conduct experiments that push the boundaries of what we thought was possible. For instance, researchers have successfully created entangled photons and observed their behavior across vast distances, proving that quantum effects can transcend spacetime as we know it. These experiments are not just theoretical, they're being used to test the limits of our understanding of reality. If parallel universes do exist, they might be interacting with ours in ways we've yet to comprehend, and these quantum tools are helping us glimpse those interactions. As we continue to refine our understanding of quantum mechanics, we're uncovering new layers of complexity that suggest our universe may not be as isolated as it seems. The development of more powerful quantum computers and the refinement of entanglement experiments are bringing us closer to answering some of the most profound questions in physics. Could these advancements one day allow us to communicate with or even visit parallel universes? While we're still far from that reality, the journey itself is already revealing how interconnected everything might be, both within our universe and beyond. Imagine a world where every choice you make splits reality into an infinite number of parallel universes, each one playing out like a different episode of your life. This isn't just science fiction. It's the kind of idea that some of today's most brilliant physicists are actually exploring with genuine scientific rigor. These scientists aren't just daydreaming. They're developing experimental methods to test whether these alternate realities might exist beyond our perception, and if so, how we could potentially interact with them. One of the leading approaches involves looking at something called cosmic microwave background radiation, which is essentially the afterglow of the Big Bang. By analyzing tiny fluctuations in this ancient light, scientists hope to detect patterns that might hint at the existence of other universes colliding or influencing our own. It's like trying to find a fingerprint left behind by another reality on the surface of the universe itself, though instead of fingerprints, they're looking for very subtle temperature variations across billions of light years. But the quest isn't limited to cosmology. Quantum physicists are also diving into the strange and wondrous world of quantum field experiments, where particles behave in ways that defy our everyday intuition. These experiments involve creating conditions so extreme that even the smallest interactions could potentially reveal clues about alternate universes. Think of it as a high-stakes game of hide-and-seek with physics itself, where the rules are written by equations and the players are some of the smartest people on the planet. What makes these breakthroughs so exciting is that they're not just theoretical musings. They're pushing the boundaries of what we thought was possible in science. These experiments aren't about proving parallel universes exist, but about finding evidence that could one day allow us to explore them, or at least understand their impact on our own reality. It's like a scientist trying to build a spaceship out of pure imagination, only to realize they've already got the blueprints. The implications are mind-blowing. If these experiments succeed, we might not just be confined to one universe, but could be on the cusp of exploring a vast cosmic library of alternate realities, each with its own version of you, me, and every possible outcome of every decision ever made. It's a bit like realizing your favorite book has an infinite number of sequels waiting to be written. And now, science might be helping us read them. Imagine standing on the edge of a vast cosmic ocean, where each ripple could be a doorway to an entirely different universe. This is not just science fiction. It's the frontier we're now beginning to explore with cutting-edge technology that might one day let us see beyond our own reality. At the heart of this revolution are quantum sensors, which are so sensitive they can detect changes in gravity or magnetic fields at the atomic level. These devices could be our first tools for spotting anomalies that might indicate the presence of parallel universes, like tiny distortions in spacetime that we've never seen before. But quantum sensors alone aren't enough to unlock the secrets of the multiverse. We also need eyes in the sky, literally. Space-based observatories are being developed with the power to look deep into the cosmos and scan for signals or patterns that don't fit our current understanding of physics. These observatories will be equipped with advanced telescopes and instruments that can detect faint cosmic phenomena, such as gravitational waves or unusual energy signatures, which might point us toward a parallel universe lurking just out of sight. One of the most exciting innovations in this field is quantum communication technology, which uses the mysterious properties of entangled particles to send information across vast distances without any physical medium. If we can harness this power, it could allow us to communicate with or even receive messages from a parallel universe that exists just beyond our own. Imagine sending a signal through an interdimensional gateway and receiving a reply in seconds. This might be the future of interuniversal communication. Another game-changing technology is the development of high-precision atomic clocks, which are so accurate they can measure time with incredible precision. These clocks could help us detect subtle shifts in the fabric of spacetime that might indicate we're near a boundary between universes. Think about it. If our universe is just one of many, then the transition between them might cause tiny but measurable fluctuations in time itself, something these clocks are uniquely suited to find. As we push the boundaries of what's possible with technology, we're not just building tools, we're building a bridge between science fiction and reality. These innovations aren't just about discovering new worlds, they're about redefining our understanding of existence itself. So next time you look up at the stars, remember, there might be more out there than meets the eye, and soon we may have the means to find out.